In this video, we are going to take a fresh look at RAG in connection with agentic framework. So this is one video that you will need to watch to really understand what happens behind the scene when it comes to RAG and how we can attach RAG to an agentic framework. So first, a quick 2 minutes intro. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. So here we have the large language model, and if a user wants to query this large language model can only respond within the limit of its training data. So what if you have a set of documents that is your knowledge base? How can we update this large language model? For that you need to have some mechanism to train, right? But we don't want to spend money in training. It is extremely complicated. It needs special machines, etc. So we need to bypass the need for training this large language model. So what can we do? One option is send this entire knowledge along with the query. So if this is a 100-page document, if your large language model has the context size to accommodate these 100 pages, you send the 100 pages along with your query. Then you can expect to get appropriate response from the large language model, which looks at the context, which is the document that you have sent. But is this practical? It's not practical because the number of tokens that you need and the traffic that you need to utilize, etc. All these things are way too much. The RAG helps us to minimize this. So that is the whole idea. So how can we do this? Let's see. So this knowledge, what we do first is we do an operation called chunking. Okay, so we first chunk. Essentially, chunking means cut the document into smaller units, maybe pages or paragraphs or even sentences. Then we convert them into embedding. So this is also called vectors. That is, every chunk will have a vector associated with it, which depicts the meaning of the chunk. So semantic representation of that chunk in terms of vector, which will have several dimensions. It can have 1536, etc., or even more. So then what do we do with this embedding? We store this into a vector store. Clear? So there is a separate operation. So there is a completely isolated operation that prepares your data, prepares your knowledge into a vector store. Clear? So let's get rid of this. Okay, so now let's place the vector store here. Vector store. Okay, so now what we do is, when the query comes in, we will convert the query to a vector or embedding. So the query's meaning will have a vector, and that vector will be used to query the vector store, and that querying is a semantic search, and that search depends on the distance between that specific query vector and the chunks. Closer a query vector to a chunk means that query's meaning is similar to the chunk's meaning. So what we do is we fetch matching chunks, maybe 3, 4 or 5 chunks, attach those small chunks, and so instead of sending the entire collection of your knowledge or the documents, we only send a small subset of the documents which are semantically close to the query. So the query goes in plain text. So these vectors don't go to large language model. Queries in plain text. The chunks retrieved from the vector database also is in the form of plain text, and they go, and then the large language model will reply back to the user. So this is the idea. So this operation is called RAG. So without having to precisely train the large language model with the up-to-date knowledge, you can continually provide the large language model with the contextual information using RAG. So I have created a set of very nice demonstration to highlight this. Okay, so let's see the demonstration. So I'm in Techie Talks AI folder. There is an Agno vector Chroma folder. We will use Chroma DB for this demonstration. So there is a 01 folder, and there I am doing Docker compose up. Okay, so this will start the web interface. Let's browse it. Localhost colon 8501. Okay, so here you can drag and drop documents. So I'll upload this Thai recipes document, which is just 14-page document that comes with Agno examples. What we will do is we will drag and place it here. So Thai recipes.pdf, and click here, process documents. So now what this has done is, this has created the chunks and then converted the chunks to embeddings and created a Chroma DB based vector store and updated the vector store with the chunks and the corresponding vectors. Now what can we do with this at this time? We can query the chunks. So I call it semantic search. So if I search for, say, curry, it will pick closely matching 5 chunks. These are the chunks. So these chunks will have some meaning with the word curry. Another word, say, Goom Sooth. Goom Sooth. So this topmost one is the most matching chunk. Okay, so all these chunks will have some connection with the word Goom Sooth. Okay, so now, so far is clear. So we have created the vector store using the PDF document, and that vector store has these chunks and the corresponding vector. So now let's query the large language model. Let's again search for this. So here it gives, say, a short, meaningful, readable explanation of that. These chunks are all disconnected units of sentences, right? Whereas when we query the large language model with the query, these 5 chunks also go to the large language model, and then we get meaningful reply. So if I ask a recipe from these chunks, it will prepare a recipe for us. See here, here's the recipe. I can even ask the macros in this recipe. So you can make intelligent questions using these chunks. Let's see. See here, calories, protein, fat, carbs. So the picture is clear. So this is what is RAG. Now let's look at the code. So this is a Streamlit application. There are lines for Streamlit which we can ignore. They're just readable. You can just go through them, like st.title will put the title for the document, header for upload documents. Then we have the file uploader. That is what we saw here, upload documents, then file uploader. And then if there are documents, and if you press the button process documents, it will call the process files function and create the embeddings and store it in the vector database. Okay, so here we also have another interesting thing where we can create a vector visualization for the chunks. Okay, so here we have the chunks, and each of these dots indicate one chunk. See, these are all different chunks. So if you zoom in, see, if you zoom in those two dots, so this is actually a reduced representation of multi-dimensional vector space into a two-dimensional space just for us to see. So when our query comes in, and if this is the vector for our query, it will find out the closest chunks for our query and retrieve them. So this is actually not correct. This is not a two-dimensional distance. It is a multi-dimensional distance which we cannot visualize. But there are techniques to measure the distance using dot product, cosine search, etc. So the vector database helps us in quickly finding the closest chunks. Okay, so here we also have show raw vector data. So this will show all the chunks, and for each of those chunks you will see there are numerous numbers or numerous hyperspace coordinates to depict the meaning of those chunks. Okay, so let's come back to our code. So this is where we are doing the RAG search. So let's understand this. So this is the text box where we are entering the query. Okay, and that is the variable called RAG query. So if the RAG query has a text, that is our query. Clear? So now if that is entered, then it will enter this loop, and there what we are calling is encoder.encode the RAG query. So here we are converting our query to an embedding. Then here we are querying the collection, which is our vector stored, and asking it to return closely related 5 chunks. So at this stage we have our RAG query and the chunks. So what we are going to do is we are going to create the context by concatenating the matching documents from this hits variable. We are calling the large language model here, and we are passing the context. So context is the RAG results, and the query goes as a user prompt. And then this returns a meaningful human readable response from the large language model. Clear? Same thing can be accomplished using command line. So let's look at the code, the command line code. So here we are first asking a RAG query, Tom Yum Soup. So here we have the semantic search results for Tom Yum Soup. So this is the score. So this closely related 5 chunks. And here we have more information about the Tom Yum Soup. So if we ask, okay, so in this Docker Compose asking for Tom Yum Soup, if I can say here macros, this is just to demonstrate the ways we can access the RAG. Let it load the application. Okay, so this is the semantic search results, and then here we have the macros. Okay, so calories, protein, carbohydrate in markdown format. So that is it for this video. I hope RAG is clear to you now. Please remember to like, share and subscribe. See you in another video. Bye-bye.